Welcome to Python for Introductory Statistics. In this video, we'll learn how to find the expected values and standard deviation of a discrete probability distribution. Let's look at this example. Here it says the number of electronic devices per household in a neighborhood and their corresponding probabilities are given on the table below. So X is the number of devices that they have, electronic devices. So for example, some have zero, and the probability that a household will have a zero is only 1%. The probability that it will have one device is 2%, and so on. And then they will have four is 51%, but these are in decimals. And now this is asking us for the expected value. The expected values are the same as um, weighted average, right? So we're going to use the same function that we had earlier to find this value. So the first thing we're going to need is to write this two values. So x will be x. So let's write it separately in a list on a list. So we'll put them on a list. So the first number is 0. Let's do it together with the probability. Let's use p for probability, right? And the probability for that is 0.01. And then the next number is 1, and the probability of getting 1 is 0.02. And then the next is 2, and the probability of getting 2 is 0.13. And then the next is 3 devices, and the probability of getting 3 devices is 0.33. And the last one is 4, and the probability for 4 is 0.51. Right? And let's close this. And now we're going to take these two and find the weighted mean. That's what expected value is. But except now the weights are the probabilities. So let's copy this. Let's go to our Google Colab. Let's open a new line here. We're going to have to import NumPy first. So NumPy as NP. And then let's paste our data values, which are the number of devices and the probabilities. And then if you remember, np.average, not mean, but average is the one that gives us a weighted mean. So we tell x is our data values or the number of devices, but now the weights uh, are, are stored in the variable p for probability. So this will give us the expected value. So that means on average, we expect about 3.31 devices on this neighborhood. And then to find the standard deviation, we'll do np dot. Now, in this case, we're going to use, remember it was covariance, so but COV, and then x is our data value. And then the weights, they're called A weights, right? And these weights are stored in P, but this is the variance. So to find the standard deviation, we have to take all of this and raise it to the power of 1/2 or the square root. So we can do raised to 0.5, and this will give us the standard deviation. So what we're saying is in this neighborhood, on average, there's 3.31 devices with a standard deviation of 1.08 if we round it.